yeah, it's on. It's live now. Okay, guys. So this is our SIP meeting in November, and the first item in the agenda is to discuss the SIPs for Meta. So since Josh is not available today, Julian is going to review the SIP, and also know that Eugene wants to comment on some new advance and progress that has been in the Meta side. So please, if Eugene wants to start, that would be cool.
All right. Hello, everyone. For the last 2 months, we've been really busy hacking the support for inline and meta and different compilers and IDEs. It's a big concerted open source effort. And I'm really glad to present the results of our progress today. So just a super quick recap. Previously, we discussed a new macro system for Scala that's based on 2 language features, namely inline and meta, where the first one, provides a facility to declare methods that inline the right-hand sides into the call side, and the second one implements compile time function execution to do meta programming. So to start with, there have been 2 directions in implementing the original proposal. The first one has been taken in DOSI, where Martin implemented the inlining mechanism, and it's already pretty mature. It's already there in the main line of DOSI. And the second effort was on my side, where I was working on macro annotations based on the meta mechanism. And one of the main ideas behind the proposal was that new style macros, as suggested by the SIP, they will improve on the current macros, which I will call old style macros, in the sense that they will provide superior tooling support. So one of the biggest problems with the old macros was that, well, their integration with tools was kind of mediocre, and it couldn't be improved with reasonable effort. So what I'm going to demonstrate today is how the new macro system works in IntelliJ. So let's take a brief look. I'm going to share my screen now. Hopefully that's allowed. All right, awesome. Here we go. So here we can see a simple project with a macro called debug. And as you can see, this debug macro, it's defined as a static annotation, much like old style macro annotations. But instead of the usual macro transform method, which is a macro, we have an inline method with a meta block inside. So what happens inside the meta block, as explained in the SIP proposal, and that's how we implement it, inside the meta block, some of the variables from the scope, namely type parameters and term parameters. So here we have the define parameter, which is the annotee that we're going to expand. They're available as Scala meta syntax trees, and they can be manipulated with quasi-quotes, this Q-quote thing here, and then they can be rewritten using quasi-quotes as well. So what happens here, I'll just really quickly guide you through the process. So this debug annotation, it can be put on methods, and after it's applied, it print lines all the incoming parameters, which happens on lines 9 through 12. It just goes through the parameters and just inserts print lines statements with the name of the parameter. And finally, it just injects this block of print lines into the body of the method. So let's see how it works. Let's say we have a simple hello world with some sort of a helper method hello. And now, if we're going to compile it and run it, oops. Let's give IntelliJ some time. So what happens here is that we not only printed hello world, but we also printed the value of the parameter to the hello function. So this shows that this shows the integration of our new macro system into the Scala compiler. And now, speaking of integration into IntelliJ, the tool support, that was one of the main motivators for the new style macro system. First, we can notice that inline modifier and meta blocks, they're fully supported by the IntelliJ. That was quite a lot of work from the team at JetBrains, from Mikhail Mutsanko. And we can also see that quasi-quotes they're fully supported, and the IntelliJ recognizes the syntax and recognizes where we can splice things and how we can extract them, in particular here in patterns. And finally, what I consider to be the main feature, the killer feature of Scala meta integration is interactive expansion. So next to annotations, we can see this icon, which says expand Scala meta macro. And if we click it, we can see the expansion exactly.
Wow.
So this should greatly help debuggability, and well, let me demonstrate that. So let's say we made a typo. Instead of pre-def, we just omit the letter. So what will happen here is that IntelliJ will recognize that the Scala meta macro needs to be recompiled. So we click this icon, we give it some time to compile the macro, and just in a moment, we'll be able to see how this new functionality of interactive expansion helps debug erroneous macros. So first, let's try to compile so basically what happened here is that in the interactive mode, we're able to see that we made a typo and exactly where it happened. So of course, if we correct the mistake here, we can make sure that everything works fine. We can compile the app and see that it behaves as necessary. And then we go here and just simply correct the quasi-code. So just to sum it up, to conclude this really quick demo, we have seen that the new macro system works, in particular the part that supports new style macro annotations, and that it's proven to work both in the Scala compiler and in the IDE, producing what I would say a pretty awesome developer experience. And now on to the next steps. I'm going to stop the screen share now. Let's see how we can do that. Interesting. No, never mind. So now on to the next steps. What I would like to discuss today is how we scale this up to implement the full proposal, and which parts of the proposal merit, well, need to be prioritized. So one of the comments that I've seen, I think it was from Eugene, that was brought up during reviews, is that the Scala Meta API is morally part of the proposal. And so we need to specify it, at least in some way, in order to see whether it lives up to expectations. So I think that our experience shows that metaprogramming using quasi-codes, which we used in that example, is quite useful and is quite natural to the people. So I think that part is pretty good. But in order to scale this up to a full-fledged macro system that subsumes def macros of today, we will need to prioritize the APIs. And essentially, what I'm planning to do is to describe the list of APIs that we're going to implement first, and then provide further experimentation in order to see how it works. And well, basically now I'd like to hear your opinion, guys. What do you think about the presented results? And how do you think we should proceed with these SIPs?
Thanks.
Awesome demo, great. Thanks, Eugene. I think it makes a lot of sense to continue with fleshing out the Scala Meta API, as you yourself suggested here. And I think there were a couple of other points made by both Josh and I in the I think it was a GitHub pull request when you were fleshing out the whole text and so on. So those were much more specific. I don't know if it's worth going through them, because I imagine you might have some answers, but maybe not all of them, since you were working on tool support mostly. I'm looking forward to see sort of the fleshed out macro API or Scala Meta API, and then also answers to the specific questions that are documented on that PR.
All right, so let's move in that direction. Thanks. Martin, you're muted.
Yeah. Is there anything you need to do on the inline side, or is that baked now?
So at the moment, in the macro annotation prototype, the inline thing, it's well, it has rudimentary support, because for macro annotations, you're looking into inline methods whose right-hand side is a meta block. So it doesn't make sense to do anything else there. but definitely when we scale up the current implementation to support def macros, we will need the inline part. So basically, the work is twofold here. First, we're going to work on supporting semantic APIs and meta blocks. And second, we will need to bring the results of your work that has been done in Dotty on the inline side into Scala C.
Mm-hmm. That's on the implementation side. I meant now is from the spec side on the SIP, whether there's anything we need to refine or flesh out. Or
so from the spec side, we need to see well, basically document the experience that the inline implementation already has in Dotty, and then update the specification accordingly. So for instance, there were a couple points about prohibition of ETA expansion and overriding that have been done differently in your implementation, and I think we should update the spec to reflect that.
Okay.
Because that's valuable practical experience, and it's definitely an evolutionary step ahead.
Okay, cool. Thank you.
Eugene, is there any progress on the split of the SIP into a SIP28 inline and then SIP29 meta?
So basically, that's something that I plan to do for the next meeting. Now that we are familiar with the practical results, now we can update our findings and then explain how these two things relate to each other and why they should be independent. So that's in my immediate plans, indeed.
Cool. Okay, so is there any concrete points you would like to discuss, guys? Okay, so let's move on then to Heather, because she's going to explain SIP24. And
yeah, so this is probably the simplest SIP that's come up. So it's repeated by name parameters. So this was, I don't know, probably, I don't know when this was added, probably a year ago or so. But the proposal is to update sort of the syntax very slightly to allow for the Varargs, like a by name parameter like Vararg thing. So that's pretty small, and I guess the only question or debate would be for the semantics or the translation rules. So there has been a bit. So basically, the translations or the however you want to say it, the semantics in this case would be that all arguments are evaluated each time the parameter is referenced in the called method. And this is what's been implemented in Dotty. About a year ago, actually. But, so it would follow that this would be, added for consideration in Scala C. But the only debate is really the semantics of it being like a function of seek or seek of function, basically. The evaluation of these things. So right now, this is actually I think that this was actually even discussed in the Dotty pull request. But there also turns out to be Seth very helpfully pointed out a Stack Overflow question where somebody would want sort of the opposite of what's proposed in Dotty, right? So right now it's like a function 0 of seek, basically, rather than seek of function 0. And as far as I understand, there's a this one example illustrated in the Stack Overflow question of when one would prefer the seek of function 0 semantics rather than the function of 0 seek semantics. So this would be kind of like the only discussion point I think that we would sort of like hash out. But yeah, that's it. I mean, it's a very simple proposal.
Should it also talk about how it interacts with ETA expansion? And potentially in Scala, we have these Java Varargs bridges.
Oh.
I mean, it's probably straightforward to talk about what that does, or how it interacts with that. But For completeness, I think, so first of all, the first point that you mentioned, and perhaps the other two should be added to the SIP.
The Java bridges should probably be forbidden in this case.
Sorry?
The Java bridge should probably be forbidden in this case, no? It's some annotation that we add anyway, so we could just make it an error.
Sure. Yeah.
I don't think there is any meaningful interpretation from the Java side. Especially if it's a seek of function 0. Oh no, if it's a function 0.
I'm not. Maybe everyone already understands this, but in case there's someone who don't, whether it's seek function or function seek, the issue is whether it's possible to force one of the arguments without forcing all of them.
Yeah.
So I think users might expect that that the arguments would be separately forcible, but in the Dotty implementation, they are not.
Yeah, I would also expect that, actually. I think that is the more general version.
Right. So the user actually the example that Seth connected the SIP to on Stack Overflow is one where there's like a try catch, and that basically only one of these functions are actually evaluated. And that's kind of, and it's a it's a cute example which one could imagine being realistic. So I have to say I also assumed the opposite functionality sort of.
And I found it somewhat difficult to decide how much it mattered because the SIP is light on example use cases.
Yeah, well, it's essentially just to remove an annoying restriction. So basically, the idea was to turn around and say, well, why have this restriction that we can't combine repeated and by name? Yeah. A priori, we shouldn't have any restrictions that make no sense. And if you decide that you shouldn't have the restriction, then I guess the implementation strategy and semantics should be the one that you can implement most easily. And there, definitely evaluating them all together is much more simpler than the other way around. The other way around requires major machinery. And indeed, we don't have use cases for that. It's unclear whether we want to do the conceptual and implementation expense to do the machinery. So that's basically what it was. There was another reason which had to do with case classes. Is that given in the SIP?
No.
I'm not sure.
But the other decision criteria, if you want to remove a restriction, would be pick the one of the two alternatives that is less restrictive than the other, because it removes one extra.
Oh yeah, no, it says the SIP says it. Sorry, sorry for interrupting. Continue, Sebastian.
So it seems to me that you can always, at definition sites, implement the function of seek in terms of the seek of functions, but you cannot do the other. So that's why it would justify the seek of functions rather than the function of seek, because it's less restrictive.
Sure, but it's much harder to implement as well. Oh yeah, so the motivation, it says there in the thing, but it's maybe a bit cryptic. So it has to do with inline. So we said that essentially inline should take, because we decided that inline functions should maintain call by value semantics. So we would not, just because the function is inline, essentially pass parameters by name, just to be clean that way. And I think that's a decision that was made on the inline side. So that means there needs to be another lightweight way to declare for inline functions that the argument should not be evaluated in the inline function, but should be passed as an expression, not as a value that's lifted out. And that was, there we said, well, yes, we have by name syntax, so let's just do that. But then we have this really annoying thing that now it means you can't have an inline function over a Vararg argument. So that was the motivation.
Mm-hmm.
And indeed, for the inline functions, the argument would be no, the elements of the array should not be separately forcible. It should be the whole thing. The whole Vararg argument should be forcible, or essentially the whole Vararg argument is passed as an expression, not the individual elements. So it has to do with inline, really. Otherwise it wouldn't make a lot of sense. But it's sort of, if we don't do that, then it will be much more awkward on the inline side.
I get the motivation now, but I guess when presented to somebody, without that motivation, I think that's still the assumption, okay, by name parameters, you should, I think that people would assume the separate forcing sort of semantics, because that's what you learn by name parameters are good for, basically not evaluating things when you don't want to evaluate them. So I just think that it's a conceptual stumbling block, although I understand the reasoning for wanting to include them. Yeah.
So essentially, my point is, indeed, the whole thing is not very important. We just need it for inline, and the main reason for including it is to say, well, it's very cheap, and there should be no. Basically, it simplifies the language. It removes a nonsensical restriction. That's my point here.
Well, maybe it was sensical in the sense that apparently several people think that what it should do is not what was actually implemented.
Well, it doesn't matter. Once we tell them what it does, that's fine. We don't need to follow what intuition is, because that way you always get a. Well, yeah, I wouldn't go that far. I mean, it's just to implement something like that, individual forcible elements, it requires a lot more machinery, and it's also in almost all cases much slower. So imagine you have the whole sequence of arguments. You'd have to individually box them all in a lim by name and these things. So that's expensive.
Sure.
So that's
Oops. Another question that I have about the how do we combine by name and Vararg? So what happens if we have parentheses? So in particular, I posted something to the chat, to the Hangout chat. Now, if you try to combine them in different ways, to say by name, what happens if we have parentheses when we explicitly specify prioritization? So
you can't. The arrow is not a type modifier, so you can't put it in parents.
Oh. No. Well, take a look at the examples that they posted in the chat.
In the chat for where?
It's the same video window.
Yeah.
Oh yeah, got it. Yeah. Well, yeah. I mean, you get syntax errors. That's what I would expect.
Well, that's what happens in Scala C. I don't know how it's supposed to work in .C. So
yeah, same thing. I mean, the syntax is clear that this is not a type. This is a parameter type. That means that it's only used at the place where it's a parameter. So you can put a type in parents, but not a parameter type. There's no production for that.
Okay, all right. So this SIP does not change that. Okay, good. I just checked, and indeed this is rejected in those both things.
Yeah.
Yeah. So I mean, obviously, one reason to just be on board with this change is because, well, Dottie's implemented it, but yeah, to be on parity with Dottie, but.
No, I think the main motivation is to prepare for the inline thing, really. And it's something that I think should be split out, because it has by itself nothing to do with inline, but inline won't work very well if you don't do this.
I guess this should be fleshed out a little bit more in the text, like the actual motivation and actual explanation why one case works for inline and the other one doesn't.
Mm-hmm. Yeah.
It seems to me that this would be a requisite to actually decide on this.
Yeah,
I agree. I think we've had some good discussion, and the proposal needs improvement.
Yeah, we've already enumerated some of the things that need to be updated.
I just want to say something that I'm super busy, so if you think the proposal needs improvement, then somebody should step up and improve it. I won't do it. So that's just fair warning to everyone.
Yeah. Okay, so at this point, if you really cannot update it, I think it's fair to let someone step up and do it for you. So if we find such a person, I think that we can review the proposal, and it's basically update the spec. And I would also recommend to just to stick with the thing that we have implemented in Dossier. Review the generic version more in the future when we have inline and other.
What I'm going to do is I put a comment to the discussion thread that explains these things, because I don't really want to go back and pull the thing and update it. And then it's either okay or somebody else integrates it, okay?
Yeah, that's okay. Okay, cool. So if someone, or if anyone doesn't have anything more to say, let's just move to static. Adrian has given some early feedback on it. I think it's very useful, the things that you have commented. Would you mind summarizing a little bit to the comments? What do you think the proposal and the author Dimitri should improve on this proposal?
Mm-hmm. Yeah, I mean, I like this proposal, and it's great that it ties together a lot of the earlier work that happened in this area. I think this goes back to 210 when Alex did the first implementation of this. So, I mean, clearly, this is desirable. And I think we're getting closer to a design that we can move forward with. The main three topics that I wanted some clarification on, or maybe rethink a little bit, is I still feel like too much of code generation is driven by an annotation here. And this is basically going back to the discussion that we had earlier, where Martin also said that how about we just emit these things static by default, and by implication we solve the other restrictions some other way. And in the pull request I added some suggestions of how we could do that. So name clashes, for example, you could look to what Scala.js does and say, well, specify the exported name or something like that for things where the platform decides that you can't do this, and give the user a way out. I'm not sure we want to go down that route, but I just kind of wanted to open the field to think in terms of what is the smallest thing we can do. How can we make code generation predictable without looking at annotations, and then fix the remaining corner cases some other way. And so the other example was, I want to be able to emit a public static field without accessors. Maybe that's a useful use case in general, even if it isn't static. So maybe that's something that we can tease apart as well. Right now we have private this as kind of a magic indicator that you don't want accessors and that you just want the field directly. Maybe that's something that can be improved while we're thinking about that. So I mean, those are kind of more usability or principle of least surprise improvements that talk a bit about the user interface and not so much about the underlying ideas. I think the hardest conceptual thing to really get our heads around is initialization semantics, and making sure that nothing unpredictable changes there. I do think that having everything emitted as static in objects where possible is going to simplify reasoning about how things are initialized. And then what was the third thing? I clicked on a link and then my points went away. Definitely had three. Yeah. Yeah, binary compatibility. Right. So how should a user reason about adding and removing a static annotation? Can we somewhat at least include a discussion section for future users to refer to? Yeah, it's of course platform dependent. And I just added a couple of links to bugs that cause surprising behavior with
Binary
earlier
compatibility
implementations.
is supposed to be platform dependent.
I'm sorry, what?
Binary compatibility is not supposed to be platform dependent.
Well,
Because there is only one SBT and there is only one MIMA. So that means Scala.js and Scala Native have to make sure that if the JVM decides it's binary compatible, then so should Scala.js. And
okay, well, I wasn't aware you guys were willing to jump on that bandwagon, but okay, yeah, great. Then it's for
well, we do. It's the only way we can use SBT's incremental compiler.
Right.
If we do that, there would be no incremental compilation. So that's
Sure.
It's just not an option.
Okay. Well, yeah, fair point. Okay, so I mean, I think that's I think where I would like to see some discussion on this SIP. I'm happy to hear what other people think.
So I guess one of the questions would be, what's our stance in general on annotations that are not strictly metadata? Because we already have precedents with @volatile, @beangetter, beansetter.
Yeah, so I mean, my thinking there is that they're very simple modifiers on what happens to the bytecode.
Well, I guess
this is much more.
Well, not the bean setters and bean getters, right? They create new methods and things like that.
Well, they basically just define the names for the getters and setters that would be generated anyway.
No, it generates
well,
them.
the additional ones. Yeah. Sorry.
Generates them in addition.
Yeah. Well, just generates another set of accessors.
Yeah.
With different names.
So it changes bytecode essentially. So well, produces some new public methods. And speaking of volatile, it has special relationship with the lazy vowels in the current SIP, in the DOT implementation, as far as I remember. So it also has some impact being an annotation as well. So I guess the question is, should we continue that precedent, or yeah? So what would be our verdict here? Maybe it's not directly related to the SIP, but I think it merits a discussion.
Yeah, I mean, I don't know. I think it's a. I mean, you're basically just extending the language with annotations. Like for something like static here, a lot of restrictions come with it. Very different code gen comes with it. If we go with the current SIP, I don't know if it really makes sense to have it be an annotation then.
Well, as long as it does not allow more code to type check, it seems fair to me. But then also that's because we've been doing that in Scala.js for some time already. We have to do platform extensions for interoperability purposes as annotations because there is no way you can change type checker. And the only restriction is these annotations, they have no impacts on what type checked. So if something works, it would have worked without the annotation.
Yeah, what Sebastian said is also my intuition here, that it ought to be an annotation. It's that it's only affecting a sort of external view of the meaning of the code, rather than what the meaning of the code is seen from Scala itself.
Yeah.
Well, but it comes with a bunch of extra restrictions, right?
But that's not, it does not allow more code to compile.
Right. Oh, okay. You're saying it's defines a subset of elements.
And whatever works and compiles with the restrictions would have the same internal semantics without. It wouldn't have the same interrupt semantics, obviously, but internally it will have the same semantics.
That's right. Okay. Yeah, I mean, that's true for this one. Assuming that we go with the one that I mean, I like that it's in objects, which kind of neatly sidesteps the issue of this capture and so on.
Yeah.
And that, I think it's also important that there are these restrictions that they have to come first in order not to have surprises with initialization order things. So.
Well, I think that's going to be, I don't know, that's a first, isn't it? I mean, that's kind of, I think one of the more surprising things to explain to users. I mean, it's easy to explain. I mean, it's easy to tell them to do that, but I think it's a lot harder to understand exactly why it's necessary. I think a lot of people don't really think about the way that objects are compiled.
Well, a lot of people don't like to think about initialization. That's why there's so many are surprised.
Yeah, well, I include myself in that cohort.
Exactly.
Yeah. I mean, that's part of my motivation, that I would like to, reduce some of the runtime semantics, move it out of the presence of the annotation, and just move it into the standard compilation, because it does have other benefits than just Java interop, right?
Yeah, I agree that we should move more things into statics if we can. But I think even if we did, and this was already done, then there's still sort of the argument for this one here to say, well, sometimes I just need to make sure it's static for interop. And,
yeah, sure. Yeah,
so.
But I would much prefer that way than kind of the other way, because if you have the regular compilation scheme and the at static demanded compilation scheme, you need to have both in the compiler, and people need to reason about both in terms of switching back and forth between them for binary compatibility. Now, if I add a static thing to a member, I have to move it up, and then later I can just leave it up there, I guess, if I remove the static thing. And I don't know, it just, I feel like it impacts too much of what.
Well,
behind
actually,
the scenes.
with your explanation now, I realize that binary compatibility is actually also an argument in favor of having an explicit add static annotation. Because otherwise, let's say you have in one version, you have a method, a static method foo, a method in the companion object with some signature. And then in the next version, you simply add a method with the same name and signature in the class.
Right.
And then suddenly, the static implementation of foo is not valid anymore. And the compiler will change the way it compiles it so that it still works. And then you have broken binary compatibility in a very, very silent way.
Right. Well, that's why I was saying that maybe we should have an annotation that controls name clash, that helps you resolve name clashes explicitly rather than doing it behind the scenes.
Yeah, but then that means you're basically now making any code that currently defines the same name and signature in a class and an object invalid. You will have to add an exported name to make it compile again. That's not going to happen.
I mean, you already can add, let's say, a final method to a superclass and invalidate the subclasses, right? I mean, it's not the first time that you have this action at distance between.
Sure, but at least it's the same namespace from a Scala point of view.
Yeah. Yeah, I mean, that's one of the main problems here, right, is that we're collapsing namespaces in the underlying platform.
Which is kind of my point, that it should be explicit.
Okay. Yeah.
Well, I would propose that if someone wants to change our precedent, he or she can submit another proposal and we can study it further. But at this point, just for static, I don't know how much value we would get by changing right now the way static would be signalized to the compiler, whether if we use an annotation or we don't, right?
Well, I think that's. So I think we will always use an annotation. The question is, if I get Adrian right, is should that annotation be more like tailrec? That means we sort of assert that the compiler should have inlined this, or should it be more prescriptive like it's now? And but I think the prescriptive one doesn't rule out the other one later, right? So you could say here's a smallish solution that's prescriptive, and we could actually try to roll this in the standard behavior and turn this then into just essentially a post hoc annotation like tailrec.
That's right.
Yeah. But I think, in a sense, tailrec is a good case for saying that there have been cases like this to say, well, here's an annotation that sort of specifies some part of execution behavior, not necessarily essentially the types or the high-level semantics. Here it just says, well, it won't overflow the stack.
Yeah. Yeah, I mean, the main concern I have is that changing initialization semantics, however subtly, is painful when we change the way that we implement it. So I want to make sure that, I mean, and I think the SIP does a good job of that, but I just want to be absolutely sure that doesn't happen.
I actually think that SIP is the only way to ensure that doesn't happen.
Yeah, well, yeah.
Otherwise, you'd have to, a lot of surprises.
What would convince you? What would we need to do to convince you?
Well, I don't know. That was poorly phrased. I'm just expressing some discomfort with my confidence in seeing all the edge cases here. I don't know. I guess, I don't have any concrete counterexamples, or I don't have any like really extreme worries. It's just something that I'm sure has got a lot of thought in for this SIP, and maybe it would help to talk to Dimitri next time and get some background story here. I also only kind of looked at the old approaches and didn't really study the bugs that we ran into too deeply. So I don't know if there's an official status code for SIPs where we want to let it just simmer a little bit longer. I mean, I guess one explicit way to say it is that I feel like the initialization part of it is there's a lot of things that we would like to change about lazy vowels and how trade vowels are encoded and things like that. That maybe we'd benefit from looking at all of those at the same time rather than tackling it for each individual problem. There's also trait parameters. So there's a lot of good thinking around how to improve language features that interact with initialization, and I wonder if discussing them together we could get some interesting simplifications. Maybe not. It's an open question. I don't know. I maybe it's not an appropriate question for the SIP. I mean, we need to just judge it on its own merits. But I don't know. Yeah. Like a consistent set of rules that help you reason about how your initialization statements get run is I think important.
The one thing we could maybe do is just convince ourselves that the rules in the SIP can be read as tailrec-like rules, so both prescriptive and post-hoc. And then if that's the case, then I guess we could have good confidence that they're the right rules, and we can just go ahead with them, because that seems like what it should be.
Yeah, yeah.
Okay, cool. So then we have some things and some edge cases to cover in the SIP. I will tell Dimitri to update the SIP, and then you, Adrian, can discuss it with him personally, and also with Sebastian. I don't know if we would benefit from waiting a little bit longer to explore all the initialization semantics. Again, mostly also because Scala also depends on static, so delaying this proposal would also delay Scala O version, the first version, 1.0.
Well, I don't know. I mean, hang on. I mean, I think you can do these things regardless of SIPs, right? I mean, it's not like you haven't added anything ever to Scala.js that hasn't been SIPed, right? I mean, I don't think we should.
No, sure, but we haven't added anything in Scala.js that would potentially eventually be included in Scala JVM that hasn't been zipped.
Mm-hmm.
That's the difference. That's why we wanted to zip the unsigned integer, for example.
Yeah. Yeah. Okay.
And here, sure. I mean, if we're forced to do the Scala.js version without the JVM version, we'll just use a obviously JS specific annotation instead. It's fine. It would be nicer if we had some confidence that the semantics for the JVM side are settled, and then we can use the same.
Oh. Okay. Well, I mean, I guess what I'll say is that I feel like we're very close.
Would just be annoying.
Mm-hmm. Yeah. So I mean, I don't expect that there's going to be a major upset in this. You know, from thinking about this more, it's just that at this point, yeah, I don't know. I like it, and I think it's the right direction, and I like that it can be implemented both, you know, pre-hoc or post-hoc. I don't know. So yeah, I don't know. Good. I think we can move on.
Yeah. Okay, guys. So let's move on.
So I have one comment then. So when we write the feedback on this SIP, what exactly do we want to explore, and can this be explored in another SIP? So maybe we can split it into multiple parts. So one part that represents the advancement of the state of the art as it is, and another part with additional feedback.
Mm-hmm.
So what do you think about that, guys?
Well, I think basically my suggestions could go in a discussion section and say, you know, there are different implementation strategies. You know, is this more like tailrack, or is this actually something that changes code generation and ref checks? And you know, just an additional, you know, little subsection in discussion about, well, how does this affect binary compatibility? Go back to what Sebastian said. And then, yeah, the initialization thing, I think just having a little discussion that motivates why they have to go first in a little bit more detail, shows maybe how that objects are compiled, and explains why, you know, gives an example of perhaps a surprising result. If you wouldn't have the restriction that static members have to come first. I guess that's my concrete feedback on the SIP, I think, is these things should be in a discussion section, because this is going to surprise people, and people are going to have questions about this, and they should be answered here. Or at least I find these kind of questions should be answered here.
Yeah, I think that's a fair concern.
Mm-hmm.
A fair concern, yeah. Mm-hmm. Anything else, Eugene? Okay, cool. So let's move on to the big, the hot topic, training commons. So Eugene is the reviewer here, but also Dale is invited today to discuss the proposal that he's championing. So he updated the proposal to champion only for one concrete change set, and I think that usually these kind of things are introduced by the reviewer, but since we have the pleasure to have Dale here, it would be better that he explains what he's chosen and why.
Sure, I wasn't ready to, but right. So if I remember correctly, the feedback from the last meeting was to update the SIP document to correctly reflect sort of what my opinion of how we should introduce trailing commas, and basically all the updates that have been happening in the comments and in the meetings, and sort of nail them down as well as I can in the document itself, so everyone can review it and vote with confidence. So the first design decision that I needed to update was the fact that we wanted to do, I wanted to allow trailing commas for multi-line only. And so that was pretty easy because we'd been speaking about it, and everyone had we talked about it, but the other part that we hadn't decided and hadn't been brought up at a SIP meeting was there are many parts of the Scala grammar that allow for trading commas separated elements. And we never really talked about what parts we should allow trading commas. So because this SIP has been taking sort of a number of iterations, I kind of tried to make it as simple as possible and provided 2 variants to vote on rather than an explosion of combinations. Yeah, what I would propose is, I'm not sure about the voting, Jorge maybe might be able to help me, but essentially there would be 2 variants to vote on. Should I explain them?
Yeah. Explain them. Well, explain them. Just say roughly what they are or what were they were proposing. Yeah.
So essentially, I'm proposing a more restrictive variant on where trading commas should be allowed. These are a sort of subjective subset of places that I think would benefit most. And they're specifically parameters and arguments. So in the specification of the language, it's class parameters and argument expressions. So that would be my first variant, where trading commas, multi-line trading commas are allowed there. And the other variant is everywhere. Every single place in the grammar that allows trading commas on multi-line, just allow it everywhere for consistency.
Can someone point us to the text where this is? I can't find it.
It's in the SIP website, right?
I just posted it to the chat.
Okay, thanks. There we go. Okay. Mm-hmm.
I also updated the implementation that I had against Scala to restrict it to multi-line and to these arguments and parameters.
Mm-hmm. Mm-hmm.
Dale, which alternative is the one you implemented?
The first one, the more restricted one.
Mm-hmm.
Is the less restrictive one substantially harder to implement?
For the most part, I don't expect it to. The only part would be the tuple-1 part. So I think the simplest thing to do there is to get it to fail compilation somehow. Yeah, that would be the more tricky part. Just so we don't steal the useful syntax for the future.
So in your current proposal, tuples themselves would not be accepted as with trailing commas.
Yeah, correct. From my understanding, those are simple expressions as opposed to arguments.
They are, yeah.
Which makes the change much smaller, but there's an argument between whether consistency is sort of the most important part, or whether making the support restricted to where it actually makes sense more important. Because there are some cases where things are separated by commas where you really don't need trailing comma support, in my opinion. So you need to burden the cost of supporting it.
Yeah.
So once we cross the Rubicon and actually have trailing commas in a couple of grammar productions, what's the main argument against doing it everywhere, or the downside?
I mean, I've never held a strong opinion of how much of the grammar should support trailing commas. I have a subset, which is the one I propose, which is the one I'm really looking forward towards. I'm not opposed to more. I'm not opposed to everything, really, from a user experience, as a user, I mean. So that's why I always sort of left it for the committee to sort of help guide me on what set makes sense.
I mean, one thing is that error messages would be confusing, because if you allow trailing commas in one context but not in the other, unless you actually catch those cases and provide an error message that says trailing commas are not supported here but are supported there, I think it could be a bit confusing to users. So the simplicity argument, unless we want to really let them swim in, error messages that are confusing, it won't hold very much, but that's my opinion.
Yeah, I would lean, well, I guess everyone knows I'm actually sort of against this whole thing, but if it is to go forward, it seems to me a great advantage that we accept a proposal that can be summarized in a single sentence. That's great. The more restrictive version is like, it's just another thing that no one is going to be able to remember exactly what's allowed or what isn't.
Yeah, I agree with that. And there is at least one production that I would find useful, and that is not, as far as I can tell, in the current one, which is this imports. There's no reason why trailing commas and imports should be a bad thing. So
Imports was in my original implementation.
Huh?
I'm not against it. It's very simple to add.
My point is not really about my personal opinion, but about making the point that people obviously have different opinions on what should be the right subsets, if there should be a subset.
I was also surprised not to see imports on the list.
So I guess that's also an argument to say, well, why not allow them in all productions that have commas?
So maybe we should talk about, from that end of the spectrum, should we support it everywhere, or where should we support it?
I think it should be supported everywhere. I mean, in every production that has commas. Or does that have a bad interaction with the tuple one thing?
Yeah, I mean, we'd have to deal with tuple one specifically.
I'm sorry, can you please explain that part? Because I think I don't really see the problem there. The tuple one issue.
Yeah, so the issue with tuple one is that the syntax where you have parentheses, some element, comma, and then closing parentheses, so a one element tuple, is syntax that we're interested in, not interpreting as just the single element as an expression, but as the syntax for tuple 1. So this SIP isn't about providing syntax for tuple 1. It could also do that, but the simpler solution is just make sure we don't parse it as an expression of 1 or string or something. That makes sense?
All right, but you still have to have a new line there in order to enable this, right?
Yeah, correct.
You have to have a, okay.
Yeah, but it would be really weird if you could write a tuple 1 that way with a new line and not with.
Yeah, we still want to make it fail at this point, I would say.
Yeah, I think that should fail. So, but then it becomes all except tuples, or should we? Or are we? No, we are still supposed to allow. Are we supposed? Just, what do we do about tuple 2 and tuple 3 and those? Do they support training commas?
That doesn't matter.
Yeah, it's obviously not an expression, so it must be a tuple.
Seth, you asked for a simple rule. I think one possibly intuitive simple rule is to say a trailing comma followed by a new line and a closing parenthesis, bracket, or brace is ignored. That would include the imports, but it wouldn't include a lot of the other things.
Dale, is that a possibility you'd considered?
Yeah, I don't have strong opinions about
that. Could actually probably be done in the scanner only. So the scanner already has the logic to say, well, if what I see is a comma, then and I look ahead and the next token is one of these closing parentheses, and I just skip that.
Yeah.
Okay, so what do we do then?
We have new information at the last second here.
I guess, is anyone opposed to that description?
Yeah.
And confident to vote on it?
I like the last wording, the wording proposed by Martin. I think it makes sense.
So does it take into account the new line? Because I'm still not.
Yeah, it says if you have a comma followed by a new line followed by a closing parentheses, brackets, or brace,
okay,
the comma is ignored.
All right.
I mean, does anyone's up or down vote on this proposal hinge on this issue? Because we don't. The committee doesn't have to decide everything.
Sure. I mean, I'm just trying to understand what this proposal actually means. So, how does it forbid the tuple 1 case?
To
me, it sounds like it accepts the tuple. Oh no, it will ignore in the sense that it will be parsed as before, just an expression within parentheses.
That's what we would avoid, right?
But it would allow a comma, but it will not create a tuple 1. I see. Okay.
It would if we hadn't considered it, and we'd be wasting syntax. Yeah.
Tuple 1s then would have to be written on a single line, according to that proposal.
Yeah, it would.
It's kind of acceptable because it's true. Trailing comma at the end of the line is sort of really you never look at that.
Yeah. Yeah.
Yeah, I think the Martin's rule was pretty intuitive. So What's your opinion on this, Eugene? Since you are the only one that are, well, it's kind of doubting right now.
I'm just trying to understand exactly what the proposal is. I like it. It seems to be quite permissive. So there's no sort of artificial list of places that where this works and others where it doesn't. Yeah.
Okay.
So would this mean that you would be for this this rule, Martin's rule?
Yeah, I mean, I think I would probably have to think a bit more, not during the meeting, to see. But I think yes. I think this sounds very reasonable to me.
Cool. So yeah, so I would rather propose to go now, but well, people are not decided on this. So let's just give it 1 week, and then I will receive the votes of all the people on this. And if this is approved, I would just ask Dale to implement the new rule and do it. We'll do the changes whenever they are required. I don't know if it would be better for you, Martin, that Dale changes his implementation from the parser to the scanner. I don't know how important is that.
I think it's pretty clear what it would do. Yeah,
because the implementation would match directly the wording of the rule. It's implemented in the parser. We have to reproduce the intent of the wording in the code. But if it's in the scanner,
it's
literally what the rule says.
Yeah. Okay, so would this proposal be accepted? I will just ask Dale to update the spec with all we have agreed here. We will. The Tuple 1 case was not really clear to me what we're going to do at the end, so we're going to...
In this case, what happens is clearly if you have a tuple 1, parentheses, x, comma, new line, parentheses, comma is ignored by the rule, and so that's just an expression. It's a parenthesized expression, but it's not a tuple, and it parses as a normal expression, and the thing that still does not parse is parentheses x
with
comma parentheses without a new line, and that could be used for a tuple 1 in the future.
Perfect. Yeah, I think it's a reasonable change. So let's do that.
Well, maybe one point. I don't think it's necessarily part of the SIP, but maybe one note at the end about. How does this influence other tools built on top of the Scala parser? So I'm thinking of Scala Reform, Scala ID, and SIME, and so on. If there could be any sort of implications or refactoring, things
Scala
like
Meta
that.
also needs to update, right?
Well,
Scala Meta as well.
Basically, any scanner for Scala has to also update.
Yeah.
Obviously.
Yeah, I'm thinking more of once you look at the trees, you will not know if there was a trailing comma or not, and if that's important, or maybe it turns out it doesn't matter.
I think we have worse problems with the trees.
Well, yeah, but maybe.
I mean, you also don't know whether you had one set of parentheses or two sets of parentheses around your expressions, or none for that matter.
Sure.
Like you cannot decide between x and parentheses, x parentheses.
Absolutely, I'm not debating that.
Okay. So let's discuss this via email if you have anything else to say, Julian.
So it's
So what's happening is that all of you will vote via email, and we'll cast your vote to me basically, and
so
I will collect the votes and announce the results as soon as I have them.
What are we voting for?
So we're voting on the Martin's rule basically, the one we've been discussing here, and also for the Tuple 1 case, the one that you just said. There is no one that has said anything against it, so I would just assume that they conform to it.
So we're voting for acceptance of the SIP with Martin rule versus rejection
versus the rejection of the
SIP.
Yeah, of the SIP.
Okay, that's clear.
Yeah, this is the kind of the final vote on this. So, yeah.
And we vote.
Here, and just will also vote via email. Yeah, you were saying, Martin?
So are you saying we vote now, or we vote by mail, or what's the procedure?
Well, those people that know what they are going to vote, they can vote now. But those undecided people will vote afterwards. So if the decided people just want more time to think about it, they can just vote at the same time as the undecided people.
Okay. Good. Fair enough. Yeah.
So is there any decided people on this?
Oh, I'm decided. I've been decided from the first.
Okay. So Sebastian is for?
Yeah, I think I'm for as well.
Me too.
Okay. Martin, Eugene?
Okay, I'm in favor as well.
I'm still a no on this.
I'll be the good cop. I'm okay with it. If the tooling guys are happy with it.
Well, totally, Scala Meta can support all syntactic details, including trading commas, double parentheses.
No one doubts.
It already
No one doubts everybody could. The question is whether everybody will and would. And
Oh, Scala Meta already is. So.
well, yeah.
And I'm for, as still for.
So Adrian, you're against, right?
He's
no,
for.
just
Adrian was
I'm
in favor as well.
You're for.
I'm going from abstain to for now that the rule can be stated in one simple line. So, Seth, you undermined your note case by asking for that.
Damn it! I quit Scala.
Good luck finding a language without trailing commas. Maybe you can do something with tabs.
I'm going back to Lisp.
Doesn't have training commas. You could go for Doki.
Go in for some parentheses.
Cool. So this is great then. So then we are 2 people for, 1 against, and 1 that hasn't voted yet. But I would assume that Josh would vote for in via email because he did it last week or 2 last
Well, we shouldn't assume anything about actual
no,
vote.
for sure.
But
Wait for Josh's votes.
But polling clearly indicates that.
Preliminarily, his vote doesn't really.
So what is exactly the score then?
So it's 6-1.
So in the worst case, it would be 6 against
2, and this means that it would be approved.
With it?
Without Josh's vote. 4, yeah. It's 6-2. It matches the 50% rule, and then it matches the 2/3 rule.
Yeah. Right.
Yeah.
Okay.
So then this proposal is publicly accepted by the SIG committee. Okay.
Yeah.
Cool. Thanks, guys. Guys, it's been a very productive meeting.
Thank you, Dale.
Have a good day.
Yeah, thank you, Dale.
All right, thank you.
Thanks, so. Thanks, guys.
Bye-bye.
Bye.
Bye-bye.